Good morning. This is Dennis Falloon, one of the hosts for the Safety Academy for District 7, and this is the 2015 series. It's actually the third year of it, and I am a consultant for District 7 Safety Office in Tampa, Florida. And usually our host with me is Anthony Chamont with Tyndall Oliver, who's also its firm works with District 7 Safety Office. And today, out of the office, Anthony is out of the office, but he's listening in. And Juan Butler with Tyndall Oliver will also be helping with hosting and also doing the presentation today. But I want to get a brief introduction to everybody regarding this. Regarding the Safety Academy. And actually, this is the District 7 Local Safety Academy. And what is this academy? It's a way of providing a series of webinars to give people information regarding safety-related issues to enhance your local safety programs in your area. It starts today, Wednesday, January 28th. The seminars run between 10 o'clock and 12 o'clock. That's the time frame that we reserve. I should read the third series, not the second. Sorry about that. We'll end Wednesday, December 16th on 2015 of this year. And they usually run a minimum of an hour, but no more than 2 hours. And if it runs more than an hour, it's due to the complexity of the topic and questions and answers. If you wanted to register, as you all have gotten an email blast to register for this, but you can go to the website. It says the website down below at tampabaytrafficsafety.com. Site page is home. ASPX is the place where you can go, and that registration link is up above. Also, that is also the same link down there where it says Tampa Bay Traffic Safety, where you can see the list of the PDF formats of the presentations and the recordings. So you can do either one based on what your preference is. This is the upcoming series of topics for this year. And as you can see, we've got some great topics. And today we're going to have Understanding Florida's Uniform Traffic Crash Report Forms. Just wanted to bring this to the people that are part of the American Institute of Certified Planners, but this session will be submitted for AICPCM credit, and you'll have to go out and check online sites for that. PDHs for Florida's PEs are available, and Larry Hagan is the PDH coordinator, and this is his link and his phone number, or to fax, and you get one PDH for attending each session, and they are each separate. And you can go back to the web page that I showed you on the previous slide, but they have the form there. So this next slide will indicate that link again. This is the link, and then you can get the form. You can submit it to Larry Hagan for that credit. And this is my contact information if you have any questions. And with that, I'd like to turn it over to Juan Butler, and he's with Tyndall Oliver, and he's going to make the presentation today. You'll have to switch over to show the screen to yourself there, Juan.
Okay, I'll do that right now.
Okay, and then you're... While Juan's doing that, I'll also mention that if you have any questions related to the presentation or anything else, you can type it in the chat, and we will deal with that.
Okay. Thank you, Dennis.
Okay.
Can you see my screen?
Yes.
Hello, my name is Juan Butler, and I'm a senior programmer here at Tyndall Oliver. Thanks for joining us today as we'll discuss Florida's Uniform Traffic Crash Report forms, and then dive into the crash data and how we use the data in areas of planning, safety, and engineering. Here at Tyndall Oliver, we're a planning, design, and engineering firm in Tampa, Florida, and I develop applications and manage databases that use the crash data. This supports the needs of our clients along with the planners and engineers in our office. Whoop. The agenda for today, we'll go over the history of crash data and provide some background on some of the information we can gather from it. We'll also cover the actual crash report form and how that has changed in recent years. We'll go over some of the nuances of crash report codes and the way law enforcement enters the information out in the field. We'll go over how the attributes being collected can help tell the story of what actually occurred during a traffic incident. And by the end of the presentation, hopefully you should know where crash data comes from and be familiar with the many attribute fields contained on the crash report. Understanding the data will help in performing inquiries on the data and getting the answers to your questions, especially if, for planners and for safety initiatives. A crash occurs. What happens when a crash occurs? Typically, law enforcement is the first to be alerted and dispatched to the crash site, especially in the case of a serious injury crash. The information that's collected out in the field is important as it is used and then analyzed by the likes of engineers and planners to make our roadways safer and help identify issues on our roadways. The reporting officer, you can see here, the law enforcement, like I said, is typically the first responder to a traffic incident. It's part of their job duties to report on traffic incidents within their jurisdiction. They are really the front line of getting reliable and accurate crash data for those who are analyzing and using the data. It's very important that the information is as accurate as possible so we can identify problem areas, and if problems do exist, they can quickly be corrected. Here you can see some of the pages of a crash report form, and we'll go over in detail in the next few slides. Most recently, there was a major change to the form that occurred in 2010. The coding of the crashes changed as new values and codes were introduced to the form. An example of this is they added electronic distraction, and this is a big safety issue now. As everyone is driving with a cell phone, and cell phones through the years have had a lot more capability. You can not only make calls, but you can text, email, surf the internet. And so to accommodate this new technology, new codes were added to track these types of distractions. This is just one example of the changes that occurred. The changes to the form meant that some of the legacy crash reporting systems needed to be updated to accommodate the new form with its new codes and values. Our office actually developed a tool for analyzing crash data, and we were one of the first to migrate the new crash report data structure for our clients and the engineers and planners in our office. We worked directly with the Department of Highway Safety and Motor Vehicles to come up with the new data structure that was tied to the new report form. So first, we'll go into section 1 of the crash report. Here you can see a copy of the actual crash report form. We'll go over the crash identifiers, the roadway information, some of the detailed crash information, and witnesses that are tied to the crash. Later on, we'll go over sections about details of each person, vehicle, characteristics of the crash, and a diagram of what actually occurred. Let me bring up the crash identifiers. So you can see highlighted here, there are a few options at the top of the report. I'll go over the difference between long form and short form real quick. The officer has an option. He can fill out what is known as a short form. This is typically what we call a property damage only crash. There aren't any significant injuries to any of the persons involved. This is the type of report that would be used for insurance purposes. If the crash has significant injuries that have occurred, then the officer can check the long form option on the report. And this is the type of report that has a lot more detailed information about the incident. Some of these include injuries and fatalities that might have occurred, along with specific vehicle, person, and roadway information. The other sections or areas of this section show important attributes of the incident, including date and time that the accident occurred. This is very important as it tells us, when the crash actually occurred. Some of the other attributes are the reference ones, like the reporting agency case number and the DHS&B crash report number. These are the key fields of linking back to each of the respective reporting systems, and they're also key to linking to the actual scanned report form from applications that interface with crash data. Some of the other important crash identifiers pertain to the location of crash. The city and county codes help identify the jurisdiction of the crash and help answer the question, which city or county did the crash actually occur in. Roadway information. Roadway information is another key piece of information as it tells us where the crash actually occurred. Hopefully the officer will input the on-street of the crash, and we would rely on the on-street and the cross-street data to help determine at which intersection the crash occurred. We can associate the crashes to the closest intersection, and also that means we can then geocode the crash based on that intersection information, basically putting dots on a map. We can also start to build reports like top location lists and answer questions like, where are my most dangerous intersections in my jurisdiction? It's very important that the information is entered correctly here so we can place those points on the map. Some agencies like FHP have moved to an electronic data entry system where GPS is utilized to provide XY data with the crash data. And they also have the ability to select street names from a list to ensure proper spelling on the street names. Crash information. So here we can see some of the crash codes that get entered on the crash. Lighting condition, weather condition, road surface condition, and collision types. They all help paint that picture of what conditions were like at the time of the crash. They can also tell us what type of collision actually occurred. Witnesses. So here you can see the section if there are any witnesses that are present at the time of the crash. They would be entered here along with the property damage of non-vehicles. This is important if they want to enter the, if a light pole or a barrier or, heaven forbid, a home was damaged in a crash. This is where that information would get entered. We have had agencies that have used that information to help recoup some monies from damaged infrastructure. So information here can be used when analyzing crash data. Section 2, we'll go into the vehicle information where details of the vehicles are entered and also the violations, if any, occurred or recorded. On this slide, we can see the many attributes that get entered pertaining to vehicles involved in the crash. For instance, year, make, style, model, they let us know the types of vehicles that were involved. This is key when analyzing what type of vehicles are happening, occurring in crashes. SUV versus pickup, versus passenger cars, versus heavy or large trucks. Other information includes identifying features like license plate, VIN number, and vehicle owner if it's different from the driver, and any insurance information on the vehicle. Here you can see some of the specific characteristic codes of the vehicles involved, body type, trailer data. All these are coded and placed on the crash report. Also, you can see details about the roadway, the traffic way. And we should see more here, some more coded attributes on the vehicles, maneuver actions, any vehicle defects are recorded here, and also the harmful event codes on the vehicle. Here, the harmful event shown is coded on each vehicle involved in the crash. Next section is any violations that occurred per vehicle. So it'll show, what the violation was, who violated, and any statute numbers that go along with the violation, as well as the charge and the citation number that was issued. Section 3. Section 3 will go over the persons involved in the crash. This will show us what type of people were involved in the crash, drivers versus pedestrians or versus bicyclists, and also if any drugs or alcohol were involved, which is an important safety topic. Person. Here we can see the information of the persons involved. The first box being a key one, as it tells us the type of person. So driver is, of course, the driver of any of the vehicles involved in the crash. A non-motorist can be checked, and that's someone who is either neither a driver or a passenger. In most, if not all cases, this will be a pedestrian. The coding of pedestrians is pretty important, as it's one of those safety hot buttons and a report that is often requested from those who analyze crash data. The other information that is entered here is name, address, date of birth, which is a big one because it helps us determine the age of the driver at the time of the crash, sex of the person, and also the driver's license data. Injury severity is there at the bottom right, and that's an important one as it plays a major part in reporting and analyzing crash data. Serious injury crash is typically defined as one that involves a fatality or incapacitating injury. Those who analyze the crash data will it'll help them identify areas where serious crashes occur, and sometimes those are weighted and prioritized ahead of those with less serious injuries and those involving property damage only. Driver. In this slide, we can see some of the coded fields pertaining to the drivers involved. So any of the drivers involved in the crash will have codes entered on them. For instance, you can see distractions, and this is where you can see they've added electronic communication devices, as well as a separate one for texting. And any obstructions that were present, or caused the driver to either hit a fixed object, or what actually contributed to the cause, and any conditions, the driver condition at the time of the crash. So all that's coded and entered for each driver. And some of the attributes that are shared by drivers and passengers, you can see here. Here's some of the coded fields that they share, like detailed sitting positions, or whether or not they were ejected, if any airbags were deployed on anyone, and if a restraint was used. And the restraint being an important one, as it's one for safety and analysis of the data, analyzing who's using seatbelts and extent of their injuries of the people who were using them versus weren't using seatbelts. Non-motorists, another big section of in the persons or people involved. Non-motorist coding is important because it can tell us if a crash involved persons that were not in a motor vehicle. And two of the biggest areas relating to this, where we see, are the pedestrians and bicyclists. With the down economy and higher gas prices, we were seeing more people relying on alternate modes of transportation, like biking, taking transit, which involves sometimes walking to a bus stop. So identifying these types of crashes where non-motorists are involved is important. It allows planners and engineers to help build safer roadways, and that all can share. And we can see where a majority of these types of crashes occur, and then take appropriate actions. If there are problems, we can correct them. Alcohol, drug, and EMS. So, alcohol, another one of those safety issues. That information is entered here and coded. You can see all the different types of codes that go along with those topics. Any of these, we can see if there's any patterns occurring, where maybe more enforcement is needed. So, and we're also showing where additional passengers are involved too under that section. The narrative. So the next section we'll go over is the narrative, and this is another important part of the crash report form. The narrative is one of those important sections in the report, as it gives the officer an opportunity to basically write a short story of what happened. And sometimes sometimes the information that is coded in the prior sections, either it's not inputted correctly, or it can be missing or just overlooked. And if some of that is missing, the analyst who is looking at the crash data, they have the ability to look at the narrative, as it can provide questions regarding vehicle movement, the impact type, the vehicle direction. So this is a useful tool to answer the questions, as the officer can provide more detailed and descriptive information that supplements that coded information, coded data. Here we can see more sections where, for additional passengers and any violations. The reporting officer, attribute point, is one of those, there's one of those key attribute points. You can see where he can put his information down there. So analysts can have the ability to see which agency is actually reporting the most crashes within their jurisdiction. And you can see the checkbox at the bottom for, what type of reporting agency it is. FHP versus Sheriff's Office versus Policing Department. Section 4, another one, another area that's really big is the actual crash diagram drawing. Similar to the narrative, it can help paint a picture of what actually occurred at the time of the crash. We'll look at that right now. Here's some examples of a crash diagram. Here we can see, some are more detailed than others. Like the narrative, it helps an analyst in determining, what actually occurred. When the coded crash information is a little vague, the crash diagram will provide a picture of the type of crash, the number of vehicles, the direction of those vehicles, and the roadway characteristics involved. Here you can see a stop sign, you can see, a raised concrete median. So, and actually the officer doesn't have to be a great artist, as there's some software packages out there that do a good job in assisting the creation of these drawings. So now we'll go into more, who owns the data, or where the data actually coming from. Crash data collection. DHSV actually are the custodians of the crash data. The information is sent to DHSV from law enforcement agencies within the state, and most recently, DHSV has outsourced the records management side to a third party. Which we'll actually cover later in later slides. So here you can see they've actually the data structure of crash data has changed. In the last 5 years, they've moved away from what was a flat file structure to more of a relational database structure. And this is big because it can support multiple vehicles, persons, violations. So this actually helps that you can see the many different fields and tables that are involved in from the crash report form to actually what gets entered into a database. And here, that third-party vendor I spoke about in a couple slides prior is FIRES, is the Florida Integrated Report Exchange System. And this is actually where local governments can go to query and pull reports for crash data. So you can drill down into, say, your county or your law enforcement agency and pull statistics and reports on crash data. It was a tool DHSV introduced through their third-party vendor, APRIS. It's a web portal. So I believe if you need more information on this, just go to DHSV's website, and there should be a link directly that will link you to FIRES and show you how to get set up for there. If you're a local law enforcement or you're an approved agency, they can get you set up with an account. It is restricted, though. It's a restricted access site. Some of the tools out there for analyzing crash data, we'll go over a few. The first being Signal 4. It's a web-based tool. It can be utilized by agencies to analyze and report on crash data. It was developed by the University of Florida, shown there. It's a pretty sophisticated tool. It has a mapping interface along with some attribute selections to report on crashes. It's got some fancy graphs and charts. And you can see there, it has statistics, live statistics on crash data. Next is a tool that we developed that is used by our clients. It is also web-based. It is known as a CDMS. It provides a series of tools, reports that help support our clients, which are mostly local agencies within the state. Some of the tools in our software include collision diagramming, interactive mapping, crash rate reporting, accident severity weighting. We have an executive dashboard, And we do full data management and geocoding of the crashes that come in from DHSMV. We also do some hotspot analysis and various reporting and charting tools that are within the CDMS. Also, a cool feature we have in the CDMS, which we call it the countermeasure matrix, or correctable crashes, we can call it. It actually groups a set of crash data attributes. They help identify, for example, those crashes that meet the definition of the state strategic highway safety plan, special emphasis areas like at intersection, aggressive driving, vulnerable road users, lane departures. Some of those are part of the SP special emphasis areas. The CDMS identifies each of these crash types based on their attributes and their codes. We basically flag them upon import, which makes it easier for our users to filter the crashes and get the answers they're looking for. And the data that supplies the CDMS is actually, like I said, comes from DHSMV. We have a good relationship with fires, and we're able to import the data for our clients. So understanding crash data. In the next few slides, we'll just go over some of the differences in interpretation between collision types. Here we'll look at angle versus left turn crashes. Like for instance, from this picture, it looks like it's an angle crash. If we were to look at the directions that were coded in the movement of each vehicle, but if we dive in and look a little closer, we can see, based on the actual, drawing of in the direction of the vehicle where they were coming from, it could be determined that the crash could be coded as a left turn. So this is just an example where we might have to, dive in deeper into the data, look at the narrative, look at the collision diagram, and see what actually occurred before just automatically coding it as an angle crash. Here's another one, similar. It looks like a side swipe, but if we look a little deeper, we can see, it can be determined it could be an angle or a left turn depending on the interpretation. Same with another one. Is this an angle? If we look a little deeper, it's an odd looking one, but it can be deemed as a left turn type crash. So you really have to look at all pieces of the crash report to see what actually occurred for each crash. Here's an example. This is a tool. Actually, this is a screenshot from our CDMS system. It's a collision diagram. So you can see here where we actually place the collision codes within a report style where you're able to query it and throw them onto a report like this and see what's actually occurring at the intersection. So basically, data-driven analysis, what can be done with the data? You can see here, based on the information supplied in the crash report form, we can provide close to an accurate representation of the collisions and what actually needs to be investigated more. From here we can access the police reports and provide data summaries and also do some thematic analysis. Here's another example of some of the tools that we provide. Spot and segment analysis. We actually can put the collision diagram or crash diagram directly on the map and make it go along a corridor. This is a great tool to show the types of crashes that have occurred. For instance, like during a safety study, we can show the crash data here, which will help tell the story about the corridor, basically, and help us quickly identify patterns and issues that are present along that corridor. I think the next slide is another example where it shows a little more detail of the intersection and the corridor. You can see the diagrams and the attributes that get placed directly at the intersection and all along the corridor. Pretty neat. So some of the areas where crash data can be used, safety studies like I just mentioned, previous slides, where we can actually look at a corridor and place each crash and collision type along that corridor. The big with safety studies and corridor studies. we can do benefit cost calculations to see, where should we be spending our money to correct crashes and what's going to get us the most benefit. And so that's a big one. Roadway design support, where can we make our roadway safer and design them a little better and they can function better and more safe. Signal warrant studies, are signals, warranted here. We can look at the crash data to see if putting a signal would solve some problems. It provides funding justification, project prioritization, and also assist when we go out and do road safety audits. So some of the final thoughts, basically, to wrap up, you want to know the crash data. If you're going to use crash data and analyze it and produce reports, trying to get some answers, some questions answered, you want to get to know it. You need to make sure you read any of the descriptive information or any metadata that exists on the data. I believe DHSV has some resources on their website, that basically describes, the codes in a little more detail and some of their data structure. Just got to take time to know the data so you know what you're reporting on, especially if you're providing that information to others. So understanding the crash report format, its attributes is key to knowing, what to look for when you're looking at crash data summaries. And just, get to know some of the crash data management systems that exist. I showed you two. You got the Signal 4, and also the system we provide, the CDMS. So, each one does a great job at, what it does. Just they might provide a little, do things a little differently, but, all of the goal is to provide tools for you to analyze crash data. So, any questions? I will go through this and see if there's any questions.
If you have a question, this is Dennis Balloon. Please type it into the chat area, and Juan and I will pick it up.
So let me go. I see a few. Let me see if I can go. Under the first harmful event field, collision non-fixed object, what does code 14, motor vehicle and transport, signify? I think John Temple asked that. The old form used to. Let me see if I can expand this out because I can't read it all. Here we go. So I'm going to read the question again so now I can see the whole question. Under the first harmful event field, collision non-fixed objects, what does code number 14, motor vehicle and transport, signify? The old form used to have a modifier of that code, such as collision with motor vehicle and transport rear end. How are the different types of crashes now differentiated from one another? Left turn versus right angle. Anthony, are you still on the line?
Yeah, I'm still on the line.
Do you see that question? I'm going to go to the screen, the slide that has.
Yeah, I'm not able to see the chat, but yeah, the angle and left turns I know changed with the crash report form. So now it's it's front to side. I mean, basically, we have angle crashes now. There are no longer we no longer have the ability to, by harmful event alone, identify angle crashes, but we use vehicle movements in conjunction with the what is now called impact type. Used to be called harmful events, to identify the harmful events. So that's the importance of those slides that Juan showed, where is it an angle or is it a left turn? Well, it depends on where the vehicle is coming from. The angle crashes, if it's an uncontrolled intersection, angle crashes are corrected by a traffic signal because someone has to have run the red light. That's the way that I like to think about the angle crashes. And then your left turn crashes, if you have that same signal, would be controlled if you install protected left turn phases. So for left turn crashes, they're coming along the same roadway, headed towards each other, like one northbound, one southbound. And for angle crashes, they're coming from parallel roadways, for perpendicular roadways on the other direction. The motor vehicle and transit, I mean, that's kind of a catch-all. I mean, I'm not sure exactly what the intent is of that particular harmful event because, to me, every collision is a motor vehicle and transit collision.
Yeah. And And you can see, Anthony, we have the, in the new form, they call it a manner of collision or impact. There is a code for angle. It's put in there with the front to rear and, rear ends. It's in with those codes. But for the movement, the right angle or, left turns, those are basically on the vehicles now, each vehicle, like vehicle movement. Is that correct?
Yeah, you've got your vehicle movements. I mean, it's how the collision diagram tool is able to identify left turns. If you have a northbound and a southbound vehicle that collide in a kind of a front to side, what is now called an angle crash, we're coding those as left turns in our collision diagram because you cannot have in our definitions of angles and left turn crashes, you can't have an angle a left turn crash where they're coming from opposite roads.
Correct. So I'll move to the next question from John Swift. Will the PowerPoint be sent to each of us after this?
No. This is Dennis. No, it'll be posted out on the website.
Okay. Thank you, Dennis.
Okay.
Yeah, I didn't do my typical introduction where we show the website for the Tampa Bay Traffic Safety Academy, but I believe on your registration link there is a link to that Tampa Bay Traffic Safety website, and in there under the education section there is a component for this Safety Academy, and
Correct.
all of the presentations as well as this recording will be posted there. So look for that to be posted there in the next day or two.
The next question, how is the CDMS collision diagram oriented with respect to corridor under study? There are no labels or directional arrows. We do have directional arrows, right, Anthony? I believe. I'm going to go to that slide. It's not your typical collision diagram. Oh, here we go. Did you hear that, Anthony?
Yeah, well, I mean, just north is up in this collision diagram tool, and it's a simplification of an intersection, and we have it set up like this regardless of the number of lanes and whether it's divided or undivided or if it's a T intersection. It's just a simplification of where the crashes go. When this report is printed, what we usually do is do a side-by-side of the aerial along with the collision diagram. That really paints the whole picture. So you can see exactly what's happening with it. And in the report that exports from this as well are the labels. The tool itself is just, in order to get to this point where you're looking at a collision diagram using our tools, you've already zoomed into an intersection so you know where you're at, and you've selected the crashes, and then you've asked for the collision diagram to populate. So this is not intended as an output deliverable. This is the tool that you're using, and you know the location you're at. The output is in a report, and those are labeled.
And also, these collision codes, how these diagrams are determined is based on the coded crash data, correct? So
yeah, the crash data attributes.
So sometimes, what's coded on the crash, doesn't always make sense, or we don't want to automatically assign a collision code. So you'll see that question mark at the bottom right there, where the users or our in-house techs can actually go in and review the crash diagram that the officer put on the crash report, and accurately put a collision code on there, so it can show up in this report.
Right. When the system determines that it cannot, with some manner of accuracy, add one of the crashes with one of these pictures. For example, if you have a northbound collision with another northbound vehicle and the harmful event is an angle crash, that can't happen. That would be a rear end. That would be a front to rear. So when there's inconsistencies in the crash data or conflicts, the system puts that crash as a question mark. And then whoever is evaluating the corridor to study the location selects those crashes, reads the report, and then properly tags them to the right picture. So the ones that are coded, we code most of the crashes, but not all. The ones that are coded, we're pretty sure about, and then anything that we're not sure about just goes to a question mark, and one of the technicians or your safety engineer reads them and codes them to the location.
Thanks, Anthony. Next question, it basically deals with the lengthy process of crash occurrence to uploading the data in the database. We're thinking ahead with automation. How can we make it easier for enforcement officials such that we can access the crash data faster? Well, actually, there was an issue with that when DHS&V was in charge of the records management and providing the data. And now through the third-party vendor APRIS, through the FIRE's web portal, we actually get the data in a more timely manner. So I believe, we get data that's 30 days out, so it's gotten a lot better. And if Danielle Joyce asked that question, if you want to get in touch with Dennis or Anthony or myself, we can see about getting you access, to the data. So, our system, our CDMS system has data that's 30 days out. I think there's some others that get it a little more quickly that have, direct links to some of the law enforcement agencies. So, but if you want to get in touch with me, my information will be at the end of the slide, and I can get you going in the right direction and hopefully get you data quickly, so you can start to analyze and report on the data. Next question, also from Danielle Joyce. There's likely to be some margin of error associated with coding. How can we reduce this margin? Basically, I think a lot of the issues start, in the field. Hopefully we can educate the law enforcement officials or the officers out there to, properly code the information. I think some of the confusion, when the new report came on, there was confusion with some of the new codes and the old way they were coding crashes. So probably better education. But Anthony, I don't know if you want to speak to that. Where can we try to reduce some error in the reporting?
The other aspect that has errors as well is the actual location of the crashes, not just the attributes themselves. And we have a couple of different systems in place to try to make that a little bit more efficient. Obviously, as the sorry, I got directions here, so I'm driving. I'm a passenger, I'm not driving. As the crashes are done more and more electronically, the XYs and the locations and all that is collected, by computer, so it's more accurate. But there's still agencies that are typing in or writing in the on-street and the cross-street, and we have a system in place that locates about 80% of the crashes that come in pretty accurately are located by their on-street and cross-street. The rest come in with the rest come in with addresses or maybe misspelled names and kind of different information that makes it a little bit more difficult to locate. An example of that that's very common is First and Main, or Central Avenue. If the city is not correct or the county is not correct, it's very difficult to identify those locations because in any given jurisdiction, particularly with one of the DOT jurisdictions where they have multiple counties, multiple cities, First and Main can happen a dozen times within that jurisdiction. So those crashes go into a list, and we have technicians in the office actually read those reports, identify where they are, and locate them on the map. So there is a manual method to identifying those crashes. So as things become more electronic, that'll improve. And the other thing that the system does as well is, as Martin Luther King is one of the examples. It's one of the street names that has the most variance in how it's spelled and how it's written. Sometimes it's MLK, sometimes it's Dr. Martin Luther King, sometimes it's MLK Jr., sometimes it can be written one of 20 different ways. And we try to catch those as they come into the system. If we keep seeing a particular street named a way that is different from the standard way that the base map calls it, we add that to the system so that the next time a crash comes in with that new different alias, it gets coded to the intersection correctly. So we map the crashes by their on-street and cross-street to an intersection. We map them on the state highway system using the linear referencing section number of milepost, and we map them with the XYs as well when they come with that. So there's any number of ways that the crashes are located, so that as long as the user understands, well, when I do a section number of milepost, what am I getting? When I do a node selection, what am I getting? When I do an XY selection, what am I getting? That helps.
Yep. I know there was some confusion when the crash form changed some of the codes for like pedestrian and maybe bicyclists, and some of the terminology change was caused confusion to the people out in the field.
Yeah, and then there's new fields now also that are not there in the old data also. So if you try to do it like distracted driving is in the new form, but it's not in the old one. So if you're doing a before and after study, you may find that all this data is missing. What's going on? It's because the form historically changes, and any time that you have one of those change points, then everything gets coded differently. So it's carrying those things forward becomes challenging.
Yep. So this next question, Anthony, this might be one for you. It says, would a motor vehicle in transport be a vehicle that is being pulled behind possibly an RV or something? Or are you not hitting the vehicle being driven, but the one in transport?
I don't know. I mean, if I was the reporting, I need to get the manual on how the police
interpretation
are taught to code that particular crash. But I mean, if I was the reporting officer and I was investigating a collision in which a vehicle rear-ended a vehicle that was being towed, I would just mark it as a rear end.
Yeah,
I would never use motor vehicle in transit because there's other more descriptive fields. So I'm not sure what the intent of that harmful event is. If anybody in the chat is a law enforcement official, they can, tell us what the proper thing to do with that is. And we can follow up also. We've got an in-house law enforcement person that is very knowledgeable in this stuff. I can follow up with him, and I'll post the answer to the question on the website. So go to that Tampa Bay Traffic Safety website and look for the answer to this. We'll follow up with everybody.
Yeah, and I think in some of the vehicle sections, there'll be codes for if anything was being pulled or trailed. You can see all the details. That's where you have to kind of dive into each section and see what actually occurred. That's it for the questions. I'm going to go back. I think there's a couple slides I skipped at the end that talk about, here we go. The workshop series.
This is Dennis. I was just going to say, Anthony put this in here, and he was trying to make sure you remember that February 18th will be the next one. It's called Use and Misuse of Crash Modification Factors, and you can switch it now, Juan.
Okay.
And also to remind you, if you're a professional engineer in Florida and you want a PDH, you need to follow this through the screen that's on there with Larry Hagan's contact information. You can flip it.
Okay.
Juan, you can move it. Okay. And this is the link to the website that will have that form to fill out, and it's under General Resource.
Yeah, that is also the website where the webinars and the presentations are posted. So
I mentioned that in the introduction, and Anthony's making a statement again that is the link to go out there and check the PDF format or the recording of the event.
And here again, here's my contact info for those who have any questions regarding crash data or anything related to what we talked about today. Feel free to contact me. This is my email or my phone number. Anthony's same number, just a different email. But feel free to contact me if there's any questions. And also Dennis's information right there.
Is there any other questions that folks might want to put into the system while we're still on? Okay. Well, with that, I'd like to thank everybody that participated today. And I think we've got some good topics for the coming year. So just stay in touch with it. I will make one other comment, and Anthony's still on the line, I believe.
Yes.
We moved from Fuse, which was the software we used for presenting the webinars, to GoToMeeting or GoToWebinar, and and then we went from SurveyMonkey to have you register for these topics versus GoToWebinar, and it's set up a little different. So when you went in there, you realized that you not only register for today, you were registered for all of those for the rest of the year. It's just a simpler process, and you get automated notices related to these webinars. And if you don't attend, it's not going to mess anything up, even if you're registered, because we do run a report of those that do register, that do actually attend the event. So we have a record of that anyway. So anyway, I just wanted to clarify that. Anthony, I don't know if you want to say anything else beyond that or what.
Yeah, I mean, what we found with the with the SurveyMonkey, there was some work that we were doing in the background to get the folks registered between the two systems from Fuse and SurveyMonkey, and we found that 99% of the people that registered, everyone here today, registered for all of them. You know, people just checked every box and said, hey, send me the notices for all of them. So what we decided to do was to simplify it and make it a reoccurring, I forget what GoToWebinar calls it, but it's a reoccurring webinar where you register once and you get the notices for all of them. You know, that's going to impact a handful of people that maybe only wanted to register for one or two, or, you know, if you no longer want to participate, just send us an email and we'll take you off the list. So it's not a big deal. But we just simplified it and had GoToWebinar manage the registration process. It made things a lot simpler on the back end for us.
Well, if there's no other questions in the queue, we'd like to end the session, and appreciate very much for you attending today, and looking forward to having you attend future ones.